Hi everyone, welcome back to PRAKASAM tutorials. In this video, I am going to discuss about introduction to random signal response of linear systems. The main intention of this chapter is to introduce the basic concepts of linear time invariant system. Linear basic concepts of linear systems and to explain how these random signals interact with linear systems. We also describe the method of determining the response of linear system when the random signals are applied as a input. So this is the linear time invariant system. This is the block diagram of a LTI system, and the impulse response is h of t, and its Fourier transform of h of t is h of omega. X of t is the random signal, that is input signal x of t, and output of LTI system is response of the system or output of the system y of t. Consider a continuous linear time invariant system as shown in this figure with impulse response h of t. Assume that the system is always causal and stable. Assume that the system is always causal system and stable system. When a continuous time response x of t, continuous time response x of t is applied to this system, the output response is also a continuous time random process y of t. If the random process x of t and y of t are discrete time signals, then the linear system is called a discrete time system. So now here in this chapter, in this unit, we concentrate on the statistical and spectral characteristics of the random process y of t. In previous chapter, we have discussed about temporal characteristics of the random process and spectral characteristics of the random process. So now here we concentrate on the statistical and spectral characteristics of the output random process y of t. And system response. Let a random process x of t be applied to a continuous linear time invariant system whose impulse response h of t, that is shown in figure. So let x of t be a wide sense stationary random process. That wide sense stationary random process x of t applied to a linear time invariant system with impulse response h of t and the corresponding output response is y of t, that is shown in above figure. The total response of the system y of t can be expressed using a convolution integral. So that is, the output of an LTI system is always, and this is output of the system, the output of an LTI system is always convolution of the input signal with impulse response. So that is y of t is equal x of t convolution h of t. So the convolution operation satisfies the commutative law. So that is h of t convolution h of t. So using convolutional integral, the output of the system is y of t is equal integral minus infinity to infinity x of tau h of t minus tau d tau. But the convolution operation satisfy the commutative law, that is y of t is equal h of t convolution x of t. So the convolutional integral is integral minus infinity to infinity h of tau into x of t minus tau d tau. So this is introduction to linear systems with random inputs. Linear systems